What is going on, guys? Vlad with SolusPLC.com, and today we're talking about the retentive timer on instruction, or more commonly known as the RTO. So it's an instruction which is used within the timer family, as the name would suggest, but it is quite different than the timer on delay and the timer off delay, which we've seen recently. Now, this little demo will tell you exactly why, and we're also going to look at an example of how you can avoid or essentially create your own retentive timer on through a timer on delay instruction. Let's jump right into this. So on the first rung, what I have is a very basic implementation of a timer on delay, and you will notice that just as you would expect, whenever I turn this bit on, the timer starts counting, and whenever I turn it off, the accumulated value goes down to 0. Now, that's the very important caveat and difference between the timer on delay as well as the retentive timer on. So the RTO, instead of resetting this back to 0, as you will notice right momentarily, it will retain, as the name suggests, that value. So whenever this bit de-energizes the timer, the accumulated value stays the same or at the last value that it was at. Now, you might ask yourself, why would you need such a feature? And the reason being is that in previous implementations, whenever you didn't have a whole lot of sensors, what people were doing is using these timers all over the place. And sometimes you could get off sequence, or essentially you get an alarm, so the process stops. And if the timers reset, then that would be critical, meaning that the process would need to begin all over. But imagine you have a certain arm that's moving forward. It's based, for example, on a VFD. It's not picture scenarios where you don't have servos yet, so you don't have a precise position, but this arm needs to move for 5 seconds. If for whatever reason this arm gets, for example, in an error or a bind, or something else happens in your system and stops halfway in, well, doing it on a T-on timer would mean that the process will restart and maybe you'd get some over travel. Now, if you're using a retentive timer on, you would stop at a certain position and you would remain, you would essentially save that time, and then when the process resumes, it would only finalize this move. So in this case, for example, it's 5.5 seconds out of 10. And of course, if you energize this bit, the timer resumes where it left off in a previous state or the accumulated value. Now, you might be wondering, how do you reset this back to 0? And of course, you can use this reset instruction tied to the same timer, and if I toggle this boolean which goes to the reset, of course the retentive timer on accumulated value goes back down to 0, as you would expect. Now, as promised, let's look at a third rung in which I've implemented a very crude version of a retentive timer on. Now, there might be better ways of doing this, but essentially what I'm doing is, whenever the timer is counting, what I'm doing is, first of all, I'm setting the previous setting that was saved into the timer accumulated setting, and then I'm also moving, whenever the timer is counting, I'm moving the current accumulated back into that same integer. Now, what this effect creates is essentially a retentive timer on a timer on instruction. So you're essentially avoiding to use that retentive timer. And the way this works is, whenever I energize this and de-energize, that value, the last value in the accumulated bit or integer, was stored in the system dint 0. As you can see, it is right there. And whenever I re-energize this, it would essentially resume at that same place where it previously left off. Now, do notice that it's essentially not really possible or feasible to keep storing this in the accumulated register, because you are essentially de-energizing the timer, so it would look a bit off if a timer is de-energized and there is an accumulated value, especially for a timer on delay timer. That being said, this works exactly the same way as a retentive timer would. As you can see, it gets to that 10,000, and of course here, if you reset, then it would immediately go back to this final state. And of course, to reset this completely, you would need to write a 0 to this system dint 0. So that's pretty much a way to avoid using the retentive, or essentially creating your own retentive timer on. And I guess, let me know if you have any clever uses for this retentive timer on. I personally do not use it very frequently, and I haven't seen other programmers use it in their own RSLogix. So the most common timer instruction you would use or come across would be the timer on delay, or sometimes timer off the delay, depending on the programmer. So hopefully that clears it up for you, and see you guys next time. Thank you guys so much for watching my content. If you have any questions on this topic, make sure to leave them in the comment section below. And if you can spend 5 seconds of your time liking as well as sharing that video if you've enjoyed it, that would mean absolutely the world to me. And if you have any suggestions for the channel, what kind of hardware, software I should be covering, then make sure to leave that down there as well. See you next time. Take care. Bye.